All right, so I'm going to go ahead and get started here. Thank you guys all for coming to the Spring Conservation Sciences Seminar Series. Today we have a local, Whitney Clark, from Friends of the Mississippi River. And for more than 35 years, Whitney has worked to improve Minnesota's environment as a staff member for several environmental organizations. During his 27-year tenure as executive director, he has led FMR, Friends of the Mississippi River's growth from a startup group with one full-time employee to one of Minnesota's largest and most effective conservation organizations with a staff of 25. Whitney has extensive experience in environmental policy, lobbying, advocacy, and education campaigns and partnership building around environmental and social justice issues. He holds a bachelor's degree in multidisciplinary studies from the University of Minnesota and teaches environmental policy as an adjunct faculty member at the University of St. Thomas. In 2017, Whitney was honored to receive the Minnesota Council of Nonprofits Transformational Leader Award, which recognizes an experienced nonprofit leader who has demonstrated success working across boundaries to develop transformational solutions. And with that, I'll hand it over to you. Thank you.
Thank you, Chris. Can everybody hear me all right? Okay, excellent. Well, happy Friday, everybody. Thanks for having me for this presentation. I was asked to talk today about the ways that an advocacy and conservation organization integrates conservation science into our policy advocacy and into our practice. So I'm going to do that today. I've got a bunch of slides. I don't know if I need them all. I'm going to kind of skim across the top of a few different issues. If you have clarifying questions as I'm going through the slides, feel free to ask them. Otherwise, I'll try to leave plenty of time at the end for Q&A and discussion. So Friends of the Mississippi River, we're a 31-year-old nonprofit organization. We were founded to be a voice for the Mississippi River. We have over the years grown in our ambition and the scope of our works to encompass all of these areas. Land conservation, we do a lot of work on planning for what happens right along the river in the river corridor. We have a growing, very expansive area of work in water, which I'll be talking about some today. And increasingly, we're doing a lot of work trying to cultivate the next generation of conservation scientists, and activists, and advocates to make sure we're placing ourselves hopefully with a more diverse cohort of people. So we've got a lot of members, a lot of advocates, and we try to bring them to bear on decisions that affect the river. We do a lot of hands-on restoration and conservation work along the river and key tributaries, and we use a lot of volunteers to do that. So we've got this growing community of people who really care about not only about the Mississippi River, but about their community. And I think the Mississippi River is one of the ways that one of the great environmental assets, not only in our community, but obviously it's very significant nationally and even globally. And it's a way that people can take action in their backyard, in their community, but also be making an impact on the whole planet. So I'm gonna just touch on three different areas of our work today and talk about how conservation sciences are informing our work. So one will be invasive carp. I want to talk about agriculture and water and climate and our partnership with the University of Minnesota there. And then some conservation science work on applying science to our restoration and applying our restoration back to science. So starting with invasive carp, this is a paper by Zielinski and Sorensen here from the University of Minnesota that was very influential in shaping advocacy work at at the Capitol. Invasive carp are a growing threat in Minnesota waters. There are 4 species of invasive carp. Am I missing one there? Must be off the page. Four species of invasive carp that are working their way up the river. These were brought to the U.S. in the 1970s to clean aquaculture and water treatment ponds. They've been steadily moving upstream. This is a map of captures, and you can see they're in Minnesota. We do not have a breeding population in Minnesota yet, but it's only a matter of, as far as we know, but it's only a matter of time. So these graphs give you an idea, dealing mostly with several different species, but you get an idea of what happens when you get to sort of an inflection point with some of these species. Here we're looking at bighead, where they just they're going along at a very low level and then they just take off, and that's been very worrisome for people concerned about the health of the Mississippi River. These carp have no predators, at least in the later life stages. They do a good job of outcompeting native fish. They're famous for how they can disrupt recreation activities on the river, and in the rivers where they're reproducing and having a big impact, they are very damaging to how people want to use and feel like they can use their waters. I put this in gratuitously. You've probably all seen these videos here, but it's always interesting to re-immerse yourself in what this experience would be like. These are silver carp, the ones that leap into the air. Imagine being out on a little fishing expedition and having to experience this, jumping into your boat, whapping you in the face. Not really what you want. So one of the things we know is it's really, as far as we know now, until Nick finishes some of the work he's working on at Macer, right now there's no cure for once these fish get established and are reproducing. So this is kind of a standard invasion curve graphic that sort of demonstrates kind of where the sweet spot is for managing these fishes, and obviously prevention is the place where we want to be. So the paper by Zielinski and Sorensen laid out some research that they'd done looking at different kinds of management tactics, and it basically said, you know what, the locks and dams we have on the Mississippi River are pretty effective at keeping these. It's slowing them down. If we didn't have the locks and dams, they'd be here already. You combine that with if you combine that with aggressive removal, commercial fishing and targeted removal programs, and then potentially some kind of deterrent barriers that could be placed in the dams, in the locks rather, you could probably really slow down the advance. So talking with Dr. Sorensen, we said, well, that sounds like a policy approach. Let's try to make that happen. Let's try to get that written into the invasive carp action plan, which hadn't been updated in a decade for Minnesota. And let's make sure that we have the funding to implement those recommendations. So there was some history on this. The last invasive carp action plan was in 2011, this Minnesota's plan. When these carp started appearing in Minnesota, one of the things the advocacy community did right away was said, let's see if we can't stop them. And we actually, a confluence of different factors led us to a point where we were able to close the Upper St. Anthony Falls lock. That lock was already no longer being used for commercial navigation, and so it wasn't a huge political lift since the commercial navigation industry didn't need it anymore. It was still being used by recreational users, but not a big lobby. And so we were able to get Congress to close Upper St. Anthony Falls Lock, effectively protecting the upper part of the watershed from invasive carp. And that happened in 2015. In the meantime, there's been research has been advancing, and we've been tracking and removing them just to varying levels of success. This is to show the lock and dam system here between Cairo, Illinois, and the Twin Cities. One of Dr. Sorensen's research projects was to look at which of the locks and dams would be the ideal one to try to, if you could place a barrier in one of them, which one would you choose if you could only do one? And his research found Lock and Dam 5 was the best one, and that's because the construction, the way that the dam is situated, there's not passage around the dam even in high water. So there are some culverts, but those would be easily blocked. There's only one lock chamber there that's in use. So if you put some kind of deterrent barrier inside the lock, you could get a significant blockage. Also, the pool just above Lock and Dam number 5 is very short, and it's thought that the distance is probably shorter than invasive carp need for the eggs to drift to successfully reproduce in that pool. So adding a little redundancy to the protection there. Also, if you could keep them from getting above Lock and Dam number 5, you would protect some really key high quality resources like Pepin, the St. Croix River, the Minnesota River Basin. It's thought that this would provide excellent habitat for these invasive carps, and so once they get in there, it'd be very difficult to get them out. So, Dr. Sorensen also was very interested in this off-the-shelf technology that was being utilized, and I'll just run this animation here, being tested at a dam.
Lock structures in the Mississippi River Basin
Down
are an
in-
essential part of the U.S. Army Corps of
down in
Engineer navigation
Kentucky
system,
at the
with over
Barclay.
150 locks
This
to move
is,
products such as coal,
a
food,
deterrent
chemicals,
technology
and
known as
petroleum. Over
bioacoustic
500
fish
million
fence, or
tons of
BAF,
products are shipped on barges, passing through locks for arrival throughout the U.S.
combines
Fish
bubbles
also
and
use
light
these
and
locks to
sound,
move upriver,
which
and
these
while movement
invasive
is
carp
good
are,
for many
you know,
native
very,
fish,
very
it is
sensitive
not
to.
for the invasive
So,
Asian carp that continue to
the
spread throughout the Mississippi
advantage
River
of the
Basin.
technology
In
like
fall
this is that you
2019,
get,
a bioacoustic fish
it
fence,
stops
or BAF,
the
was installed
invasive carp
below the
from
Barclay
moving
Lock
through.
entrance on the Cumberland River to test the BAF's
And of course,
effectiveness in deterring
does
Asian
nothing
carp
to
movement
inhibit
upriver. The
the
BAF
coming and
produces a
going
bubble
of
curtain along its
watercraft.
entire length through which
And,
lights are flashed and sounds
It apparently
known to
has
be
very
audible
little
to Asian
impact
carp
on
are
the
emitted.
passage of native fish. So that's basically how it's supposed to work, and you can see the
Asian
little
carp
guys
move
coming up
upstream,
and-
particularly in the
and,
spring, and will encounter the
like it.
BAF as they approach the lock.
And some really interesting research happening right now over at Macer that Nick was good enough.
We
to
anticipate
show
that
us the
Asian
other
carp will
day.
be startled by the bath and deterred from moving into the locked chamber and thus further upstream.
Technology.
However, studies to determine their actual responses are still
So
ongoing.
that's how.
Interim results may be available as early.
Supposed to work. There are other deterrent technologies which may also work. There's an acoustic only underwater deterrent system. We have one of those in operation at Lock and Dam 19 in Iowa. And so there's still, I think the science is still out on what's the most cost-effective deterrent technology, but we set about trying to, basically get funding for management, these management objectives, including a deterrent. Have incredibly, the Minnesota Department of Natural Resources, who's, that primary authority within the state for managing invasive carp, wasn't cooperative with us. They actually opposed an appropriation in 2023 in the biennial budget for building a carp deterrent in Lock and Dam number 5, which was disappointing to us. While I was testifying at the Minnesota Senate, the day I was testifying at the Senate, there were big headlines in this is last winter, this time last year, big headlines in the paper about a major catch of invasive carp, silver carp, just below Lock and Dam number 5. So it's kind of a perfect media event to highlight the need for this. We were not able to get the appropriation last year, but we came back this year. And I'm happy to say that earlier this week, the Lessard Sam's Outdoor Heritage Commission provided $12.1 million for the DNR and 2 federal agencies, the Fish and Wildlife Service and the USGS, to build and install a deterrent system in Lock and Dam number 5. So that's huge milestone. We now have 3 agencies working on it, 3 agencies responsible for it, and they've got the money that they're going to need to do it. Let me move now to a different area of our work, and we can come back to any of these slides and any of your questions later. Wanted to talk about our work in the area of agriculture and water quality. So our water work at Friends of the Mississippi River starts with this vision. It'd be great if the river was truly healthy and supported all the, fully supported a healthy aquatic ecosystem. It doesn't right now, as you probably are aware. Picture tells a 1,000 words. This is, of course, the confluence of the Minnesota and Mississippi River at Bedote, Pike Island there, and you can see the huge load of sediment carried by the Minnesota River joining the relatively cleaner and clearer Mississippi. This is just looking at where that pollution is coming from. We've got primary source of nitrate is agricultural land uses, cropland tile drainage being the most significant share, but cropland groundwater, shallow groundwater that feeds our surface waters is another big segment of that. The trends are not good on nitrate, despite the billions of dollars we've spent in state and federal funding to try to manage nutrients. We're not really seeing trend lines for nitrate that are encouraging. Part of the problem is the mix of crops that we grow on our ag landscapes. Something like 17 million acres of cultivated land in Minnesota, and we have this situation. Some of you have probably seen these figures before, but we have what we call the big brown spot. This huge segment of our ag landscape that is uncovered and bare, does not have living roots for a big chunk of the year. So this map is showing the chlorophyll through the year. This is April, May, starting to shrink the big brown spot, but still quite a bit of brown there in southwestern Minnesota, even in May. We've got the full growing season here in June, July, and then by October we're going back. So of course that is the time. It's during the shoulder seasons when a lot of the runoff happens. A lot of the pollution sources run off. We have catastrophic soil erosion. Of course, you'll all be familiar with the hypoxic zone in the Gulf of Mexico. And it's not just our surface waters, but drinking water is affected too. This is a map of contaminated drinking water wells in Minnesota. Impaired waters in Minnesota. 40% of our waters and most of our streams and rivers do not meet water quality standards. This is wells with elevated nitrate. These are public water supplies with elevated nitrate. You can see the karst region, southeastern Minnesota, the central sands is where are the main areas where we have nitrate contamination. But this problem is not getting better. So maybe about 10 years ago, we were thinking about this and long been advocates for a host of policies and practices to address agricultural pollution, cover crops, reducing tillage, drainage management techniques that have an impact on reducing runoff to our waters. But the Minnesota Pollution Control Agency published a report back in about 2013, 2012 called Nitrogen to Minnesota Surface Waters. And they did some modeling in the back of that report looking at, well, what would it take to meet our nutrient management goals? 45% reduction of nitrate is what's needed. And we looked at these figures and said, oh my gosh, we're never going to get there. So to reach our nutrient management goals, we'd need 100% nutrient efficiencies. That means 100% of fields fertilized at 80% of maximum return to nitrogen. That would effectively mean, most farms in Minnesota would be revenue negative. We're not going to do that. We would need all these drainage reforms. We would need all these things. And we just said, this is implausible. It doesn't look like we're going to be able to get to our water quality goals if we continue to follow this path, to sort of use the existing tools that we have. And of course, that's, when you look at what we're doing, how we're trying to address this, both in state and federal policy, it's basically relying on these tools that we know mathematically, physically cannot get us to clean water. And that led us to think about, okay, well, if we're going to do this, what can? So this is more from that report, looking at phosphorus on the left, nitrate on the right. And you can see the large parts of these bars are living cover. So they said, we're not going to get there if we just do all these things. We really have to do all these things too. We said, okay, well, how would we do that? How would we get that much living cover on the landscape to get to that goal? Around that time, we were starting to get to know some of the faculty here at the University of Minnesota who were innovating these new crops and new cropping systems winter annual and perennial crops that can be incorporated into our existing industrial ag production systems that sort of mimic or provide some of these ecological services that mimic a natural landscape, basically having living plants, roots in the ground year round. So we said, okay, well, this is promising. This is interesting. This would be, a way that we could sort of marry the markets to the needed conservation practices in kind of one set of policies. And so we began working very closely with our friends here at the University of Minnesota and the Forever Green Initiative, and we've actually formed a partnership called the Forever Green Partnership that sort of attempts to broaden the scope of disciplines and partners that are thinking about how to make this transition in agriculture. This is a graphic that just kind of shows you the difference between the conventional systems and what they look like this time of year versus same time of year, April, with winter camelina in the lower one and Kernza in the upper photo. So you can see, it doesn't take much imagination or science training to know that these different systems are going to perform very different ecologically. We're very excited about the advent of these new winter oilseeds that are being developed right here on campus. These are oilseed crops that are planted in the fall and they're harvested in the spring before the next summer annual goes in. So if you're a farmer, you're getting, in a 2-year cycle, you're getting 3 harvests of commodities, not 2. And you get all sorts of ecological benefits from having these plants in the soil during that time. Camelina is one, pennycress is the other, and they're both on view just across the street here, if you want to go out and take a look at them. This is looking at the environmental performance using lysimeter data from the university of different cover crops, so and tilling methods. So you can see the nitrate and leachate here from the different systems, and you can see that pennycress and camelina are delivering really superior benefits. Unlike conventional cover crops, these are commodities. Conventional cover crops are an input cost. They're planted and they're terminated in the spring. These farmers actually get paid for. So as we have gotten into this more, we've realized, yes, we need these new technologies, these new plants and the agronomics that support these plants. But it's not going to work if there aren't markets for them, because that's the whole idea, is that you've got to have people who want to buy these so that farmers will feel confident planting. So, a big part of our work has been around generating and thinking about what the markets for these crops are going to be. And there's a lot of work happening here at the university and in policy discussions about how to stimulate and support these markets for these crops. So Friends of the Mississippi River is one of the organizations that's working on this, both at the state and the federal level, pursuing new policies to support these crops in these markets. The ECO program here in Minnesota, developed with the Minnesota Department of Agriculture and the Forever Green program, is about de-risking grower adoption, getting these crops on the landscape, and sometimes targeting them in places where they can have an impact on water quality areas. So planting them, for instance, in drinking water, DWISMA's drinking water supply management supply areas. And working on the value chain and enterprise development. So in a conversation a few years ago with some of the businesses that are starting up and trying to sort of be the businesses that bring these crops from the farm gate to the market, they said, you know, it's hard for us to compete with the big commodities and these established, these other big established commodities and their supply chain businesses. What if we had like a grant program in Minnesota? We said, well, that sounds like a great idea. And that very year, this is 3 years ago now, we went to the legislature and made that case. We got $1 million for a grant program for continuous living cover value chain businesses. We were able to renew support for that last year, and we're back at the Capitol again this year, arguing for another installment of funding for that program. At the federal level, we were working on policies to de-risk these crops as well. I can go into some of that more later if you'd like. So these are other potential policy innovations that would help to advance these crops. Obviously, for a nascent set of crops, commodity crops, we need all these other things too: technical assistance. We need to advance the agronomics. We need to work with farm lenders for these multi-year crops. So that's the water quality and ag space. I didn't touch on, but we can in discussion. We can talk about some of the climate impacts, which I'm very excited about. But before we do that, let's just talk about one more example of utilizing conservation science to drive some of our work. So the first two were areas where we're doing policy advocacy and utilizing science to drive that. As I said earlier, Friends of the Mississippi River has a land conservation program where we're thinking about protecting and restoring natural landscapes along the river and key tributaries. So we work with landowners to protect land through fee title, acquisition, or easements. And then we have 4 ecologists on staff, several of them trained here at the University of Minnesota, who write natural resource management plans and then work with contractors and several sources of steady funding to restore and manage these lands. So we do planning to try to look at where these how we can protect and connect these different patches on the landscape. We've got 42 active restoration sites where we're proceeding driving management objectives at those sites. At our sites, we have more than 20 species of greatest conservation need, rare species that we're working to restore. So, as most of you will be familiar, it's not enough just to protect a piece of natural land. Even relatively healthy, pristine landscapes are subject to degradation because of invasives. One of the big challenges is buckthorn, and so this is one of our main objectives across almost all of our restoration sites, is thinking about how to get rid of the buckthorn and keep it out. So we've been doing some research to try to address that, think about how to accomplish that. And, you know, different sites have different needs, constraints, exigencies that require different methodologies. So this is some research that we did on one of the restoration sites that we're working at, Hampton Woods, which is a newish wildlife management area down in southern Dakota County. It's along the Vermilion River there, one of the important Mississippi River tributaries. It's the largest woodland remaining in Dakota County. So this is looking at 4 different methodologies here. The first one is forestry mowing. People familiar with the forestry mower? It's a big like a backhoe with a big spinning head on it that just basically chews up anything woody and spits out a bunch of wood chips across the landscape. So first one is forestry mowing with immediate stump treatment. That's treating the buckthorn stumps with an herbicide. Number 2 is forestry mowing followed by a fall herbicide treatment. And number 3 is forestry mowing twice. So going back the next year, so two forestry mowing. And the fourth one is cutting and treating the stems. So you cut the stems, you treat them with herbicide, and then fall foliar treatment. And from our research plots, we found number 2 was the most effective. We had the fewest seedlings after treatment and the fewest resprouts. So this is data that we can then use to share with other practitioners who can employ that methodology. One of the things that we have at our disposal, because we're doing restoration, we have funds to do restoration, is that that's one of the barriers to academic researchers doing this, is it's costly to do a restoration like this. And since we're already doing it, we can implement these experiments. There are a lot of tools in the toolbox, and different tools work at different sites, as I said earlier. This is another buckthorn management tool that we have been experimenting with. Some of you may have heard in recent years, the Minneapolis Park and Recreation Board and some other local units of government have taken steps to limit, or in some cases, try to prevent any kind of herbicide, pesticide use on the public land. Of course, it's always better to minimize the use of herbicides that can impact other species. And so that's always a goal. It's not always possible to manage buckthorn effectively without using it, but we wanted to see, what could we do? And so we've been experimenting with this methodology that does not use herbicides at all for locations where, it really would be better if we didn't use it. This is called critical cutting method, and since 2019, we've been doing research on this. So we found that cutting these stems, which we did with volunteers, this is down at along the Mississippi River in the gorge in Minneapolis. The idea is to time these cuts after full leaf out in the late spring and before nutrient drawdown in the early fall, so as to maximize the amount of nutrient stores that you're removing from the plant. And we found that early June and mid-September have worked best so far for this timing. So there's one initial top cut that leaves a stump about 3 to 4 feet high, and people wonder why we would leave it there, because it's easier to find later. And then we come back later and we cut the resprouts, and then we would come back the next year and cut it again. And we're finding that after 2 years, we've got stem death on these plants. So these are some additional, this is coming back and removing the resprouts. Removing the resprouts again. One more resprout removal, and you can see them fading away. So this is also one where we've then been able to write about this, put this back out to practitioners. This was written up in the DNR Conservation Volunteer, the last issue that came out. So doesn't work at all the sites. There are some sites where there's such a huge infestation that it would make no sense to do it this way. It'd be very, very costly. But for sites where you can and where there's a high sensitivity or high public use, maybe this is a good way to do it. We have some local volunteers that we work with to manage some of our sites who've said, hey, we can do this in less than 2 years because, you know, we can come out every month and cut these back and cut off the resprouts. And they found that they're getting stem death within 1 season. So not impossible, but it's about tailoring your methodology to the site and the constraints you have at a site like that. Let's go over that one. Just for time's sake, I'll maybe skip over this and move to one other. These are some of the papers we've published. Our conservation director, Alex Roth, has a PhD from the university and is really interested in continuing to publish. So integrating these things into that. One of the things I wanted to show you before I finish, though, is this this prairie seeding experiment we've done up at the William Holton Conservation Area along the Mississippi River in Elk River, Minnesota, right at the confluence of the Elk and Mississippi rivers. It's about a 360-acre site. This is what the site looked like after it was protected, but while it was still in agricultural use. While we were doing this, we wanted to, and here's another aerial shot that shows the scope of that. You can see the Mississippi there. We wanted to get more information about seeding methods and species mixes. And so we designed this experiment with research plots in each of these 6 areas across the prairie portion of this restoration. And we're looking at 2 different types of seeding. One is broadcast seeding, where there's a machine, I got pictures of it here, that just kind of drop the seeds on the surface. And the other is a drill that pushes the seeds down at a uniform depth into the soil. And then we're also looking at 30, 50, and 70 species mixes. This is the look at the aerial look at the site as we were prepping it for the broadcast seeding. There's the broadcast seeder. You see the guys dumping the bag of prairie seeds into the hopper there, and it just goes across the land and drops them. And we do it in a crosshatch so that the prairie seeds aren't in uniform rows. This is after year 1, year 2, year 3. We did a burn, saving some of the. We don't burn the whole site at once, so there's a refugia for wildlife. We're really interested in seeing which of these combinations of seed mixes and seeding methods give us the most species diversity in the prairie over time. the more diverse species mixes are expensive. So, you know, if you're using a 70 species mix, you're spending a lot more per acre. And we'd like to know, you know, do you actually get more established diversity? Or would it be better to use a less diverse mix when you're doing your seeding? So I'm sure you're curious about what the results are, and I'm afraid I can't really tell you yet because this is a long-term experiment. It does appear that the at least now in year 5, or after last year, it appeared that the broadcast seeding had a slightly more diverse mix of species. But it will be really interesting over time to see what the results are. And it's our expectation that we will publish the results, and hopefully this will be something to be useful for people who are managing prairies elsewhere, just to kind of make sure we're getting the results that we expect when we spend all this money on a prairie restoration. So there, I finished my slides, and why don't we just take some time now, open it up to Q&A discussion.
Well, it wasn't now before is that just the soils thing, or is it less testing the Southwest? Because I think the Southwest is being heavier.
Yeah, I think what you're seeing is a big impact of the soils there. It doesn't mean there's not a lot of nitrate pollution there, but it's not as prominent in the groundwater. Yeah.
Mr. Whitney, I have a question for you, if you got. This is Satish Gupta. I think there are a couple of, can you hear me?
Yes, we can, Satish. Thank you for joining today. Let me hold your question for 1 second. We just took one before you, but I'll come right back to you.
Okay.
So your question, say it again.
Are farmers receptive to those new crops?
Yeah, I mean,
Repeat the question.
Oh.
So that people.
yes, yeah, repeating the question. The question is, are farmers receptive to these new crops? And specifically, you're asking about the winter annual crops? And what's being done to promote them. So, yes, I would say farmers are interested in anything that they could grow that they could make money on, especially a crop that you could grow on land that's you're not growing anything else on in the winter. But, you know, farmers are business people and they want to make sure they can sell the crop. And so we're at that early stage of the development of these crops and the markets that, you know, there's not the kind of market demand for widespread adoption yet. Friends of the Mississippi River released a report this last fall where we were working with economists to predict what the likely market pull for a suite of continuous living cover crops and cropping systems might be in 2035 and 2050, and what kind of ecological benefits we might expect from that level of scaling. The report, using a moderate adoption scenario, so not wildly optimistic, what if all these crops take off amazingly, and not a super pessimistic scenario, but moderate adoption, if things just are kind of bumping along. This report projects we could have 5.5 million acres of continuous living cover crops on the landscape in Minnesota. It's roughly a third of our cultivated acres. This would be a mixture of grazing pasture, winter oil seeds, and perennial crops like kernza. If we had 5.5 million acres, we can, because we have a good idea of what the environmental performance of these crops are, we can use a coefficient model to basically tell us what kind of ecological benefits we get. And our report found that with 5.5 million acres of CLCs, continuous living cover, we'd see about a 23% reduction in nitrate to Minnesota surface water. That's all Minnesota surface water. That's not just on those acres. So massive, massive reduction in nitrate. Remember, our goal is 45% reduction, and the trends have been upward. Even better on sediment, because these systems are really, really good at holding the soil in place and preventing erosion. So 35% reduction, according to this report, in sediment delivery to Minnesota waters. And all of that with a 20% net return for producers. So pretty exciting potential, but we've really got to be doing the work on the markets. One of the big markets that is very, very promising and very exciting is biofuels. So we're at a moment in history that many people are not really thinking of yet or aware of yet, but the EV transition has begun. We're in 25 years, none of us are going to be driving internal combustion engine vehicles around. They're being phased out. It's not happening as fast as we'd like it, and there are a bunch of reasons for that, but we're going to be transitioning to electric vehicles. 40% of the corn crop in a big chunk, maybe 10 to 15% of soybeans that we grow in Minnesota are for car food and vehicle food. So as that market goes away, what's going to replace it on the landscape? So that's one big question. And then, there are segments of the liquid fuel market that are going to be hard to electrify. So airlines, aviation fuel is one of them, marine, rail, heavy machinery, biodiesel. Those are going to be areas where there's going to be a significant markets for sustainable fuels, particularly the sustainable aviation fuel market. One of the great things about these winter oil seeds, because they are grown in the winter, is that they don't have indirect land use change adder to their total carbon footprint, to their carbon intensity score. They don't, when you're planting something on land that would not have been planted to crops, you don't have to account for that crop being planted somewhere else and having a carbon intensity. And so they are by far the lowest carbon intensity feedstock. And they have these other environmental benefits. So one of the things as the sustainable aviation fuel market comes online is, we want to try to make sure that the winter oil seeds are the predominant feedstock for these new low carbon fuels. And that if that comes on, and if that was the case, we could potentially be producing all of Minnesota's sustainable aviation fuels from winter oil seeds here in Minnesota. And the benefits would be many, would be great, and many more acres than 5.5 that we identified in that report. Satish, we can take your question now. Thank you
All
for
right.
waiting.
Well, thank you very much. That was a nice presentation. I have a couple of comments about your nitrate problem as well as the sediment, especially the Minnesota River and the Mississippi River Junction. And I think you are well aware of those things, and you kind of hinted that you didn't have time to talk about the climate impact. I think when you make a presentation like this for the students and the city folks, it'll be kind of useful if a full description is given, and you are well aware that much of the sediment problem in the river is from the river banks in the Minnesota River Basin. And nitrate too, the landscape is such that there are a lot of depressions, and the water getting out of that landscape is very difficult. So if we want to have agriculture, we are going to have some tile drainage. And the problem with the tile drainage is nitrate, but there's an increase in nitrate drainage no or losses because we are getting a lot more precept no than we used to get. So I think my comment is I appreciate the presentation that you gave, but it'll become nice when the nonprofit groups give a little complete picture, even if it doesn't go your way. I think those city folks, they have a little better understanding of the problem.
Okay, thank you. Were people in the room able to hear that? Okay. There's a lot. I don't know I don't know how well I can summarize that. One of his comments was that a lot of the nitrate nutrient, especially phosphorus delivery to Minnesota waters, especially in the Minnesota River, is coming from stream banks. And this is driven by increased precipitation and increased flows from agricultural drainage. So we've plumbed the whole agricultural landscape to make sure that corn can have nice dry little feet. And so a lot of the pollution is coming from the erosion of stream banks in that system. I think the point that I would make is if you can transition our ag systems to be predominated by continuous living cover agriculture, either perennial crops or winter annual crops, you're doing a lot to take up nitrates by the roots in those systems. You're holding the soil in place. You're taking up water, so you're also reducing the some of the rate and volume of the discharges, especially in storm events, because a lot of the water that falls on the landscape is dissipated through evapotranspiration. Obviously, if there's no crops on the landscape, there's not much ET happening. So appreciate the comment, Satish, and you and I should maybe talk offline about ways that I can incorporate that more into this presentation if I give it again.
All right, thank you.
So we have just a little bit of time left here, but we have one kind of quick last question. So someone asked in the chat, wondering if you considered working with funding downstream the Mississippi, we're kind of in the headwaters of Mississippi, and there's obviously a lot of states Mississippi goes through. So if you guys are doing any of that or looking to do any of that.
Yeah. I mean, that's one of the great things about working on a river is you can't be too parochial. Anything you do good up here helps people downstream, and also you want to be working up in the watershed because everything they do up there affects us, right? So, yes, there are some major policy initiatives that we're very excited about. A couple of years ago, I got a call from Congresswoman Betty McCollum, who wanted to talk. And at our meeting, she said, Whitney, I've been very supportive of the Great Lakes Restoration Initiative for many years. It's a very, very popular, bipartisanly popular federal program that's delivering $300 to $400 million per year to the Great Lakes states, and a lot more in some of the recent budget bills. Are you familiar with it? I said, yeah, I'm familiar with it. It's, we work in a different basin, but she said, why don't we have something like that for the Mississippi River? And of course, I'm thinking to myself, well, okay, Betty, one of us is a very senior appropriator in Congress, and one of us is, runs a little nonprofit in St. Paul, but she said, would you help us develop something like this? And so, long story short, we have developed an analog to the Great Lake Restoration Initiative for the 10 main stem Mississippi River states, called the Mississippi River Restoration and Resilience Initiative. And it's different in its aims and kind of what it would fund, but it's very similar in terms of being non-regulatory, coordinating agency management of the river and supercharging funding for those programs, and it would affect all 10 states. So we have a coalition of NGOs up and down the Mississippi River, all 10 states. We have a national coalition of which I'm a co-chair. And the bill was introduced in the previous Congress. That did not pass. It doesn't look like it's going to pass in this Congress either. But I think there's a good chance in the next Congress, depending on how the election goes, that we could get that passed. And, that would be an example of, a federal policy that would benefit all the states for all the main stem states for the Mississippi River.
Thank you. And with that, we're pretty much out of time. So thank you again to each for.
Thanks for having me.
Here.